Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the lecture number 7 for the course series of Data and Computer Communication. My name is Engineer Jaffar Ali and I am your instructor for this course. So let's start with the recapitulation of the last lecture. In the previous lecture, we have discussed about the transmission medium that is involved from the physical layer of the transmitter to the towards the physical layer of the receiver. So if this is your user end, and this is your last layer, that is physical layer, and this is your receiver end, and this is the last layer of this basically layer 1 of the physical layer of the receiver end. So the medium between this is known as the transmission medium through which the channel through which the data is being transmitted. So this is your transmission medium. We discussed about the transmission medium, their types, their classifications, that how you can classify your media into two types, that is guided and the other one is unguided. We also discussed several types of guided media, which includes twisted pair, and the further two classes were STP, that is shielded twisted pair, and UTP, that is unshielded twisted pair. So we also discussed these two types, and there are several specifications that we discussed in the last class. After that, we went into the detail of the coaxial cable. We discussed how this coaxial cable is much more efficient as compared to this twisted pair cable, and how this performance of this coaxial cable gets improved. Similarly, in the last we discussed about a kind of cable that uses basically a glass or a plastic core as a conductor through which the light is being transmitted as a signal. So that is basically fiber optic communication, and we discussed about the specifications and the performance and the phenomena behind this fiber optic communication, that was total internal reflection. So we discussed these things in the last class, and we also discussed some kind of transmission impairments in the last class, noise, attenuation, etc. That how these things destroy or corrupts your signal or your data information. Uh, in the late section of the lecture, last lecture, we discussed about the unguided media, that is basically wireless media, and we discussed several types like radio waves, microwaves, satellites, infrared, and many more examples as well. And we discussed the specification of specifically these particular scenarios where we use radio waves, microwaves, and infrared as well. In the last of the lecture, we discuss about the interference that is involved in the wireless transmission medium. So that's it. That's all for the previous lecture. Let's see what is the topic that we are going to learn today. Today's topic will be similar to kind of modulation, but instead of modulation, we are going towards digital data to digital signals. We know that modulation, in modulation we converted the digital data into analog signals because of the medium of that thing. The medium was kindly analog, but this time we are going towards a kind of medium which is mostly digital. So that is why you have to convert your binary data or digital data towards digital signal. So what is the motivation? I just told you that. What are the techniques that are involved? That techniques are basically known as line coding techniques. So and this is the last topic for the physical layer in this course. This is will be the last area that we will be focusing on. After completing this physical layer or this topic of physical layer, we will go towards the data link layer, and we will start with a review of the data link layer, as well as we will look at some kind of protocol, that is medium access protocols or medium access control protocols. This is MAC protocols, and in that we will look at random access control protocol as well. If the time allows us, we will also start data link layer, but let's see how long it will take to this completion of this line coding techniques in the physical layer. So let's start with the motivation, that why do we need to convert your digital data into digital signals. You know that mostly the signal, the channel is analog, so that is why you have to modulate your signal. But instead of modulating, if the channel is basically digital, so there is no need of modulation. Instead of modulation, you can do line coding. The line coding is a technique in which you can convert your digital signal, digital bits, or digital information, or digital data. You can see that this is your digital data in form of ones and zeros, and now you can have to convert into a digital signal because the medium is digital. So that is why you have to use a kind of encoder that will convert your digital data into digital signal. An encoding scheme is an important factor in how successfully the receiver interprets the incoming signal. So we will discuss different encoding techniques, and these encoding techniques are basically known as line coding techniques. So encoding techniques in data communication, transmission medium is a pathway that carries the information from the transmitter towards the receiver. You already know that we use different type of cables or waves to transmit data, but this data is transmitted normally through electrical or electromagnetic signals. So line coding is a technique or a process that converts your binary data into a digital signal, and this is known as line coding technique. If you have a digital signal, let's say 10101, this is your digital data basically, and you want to convert this digital data into a signal. So you can see that we have converted the data into a signal 1011 and 0. So this is signal generated by the digital signal generated by the digital data. So let's see, there are several kind of line codings, and we will try to learn all of these in today's class. This is the hot topic for today's lecture. We will look at four major types. The first one is unipolar, the second one is polar, the third one is bipolar, and the last one is Manchester. Similarly, the unipolar is divided into NRZ and RZ. Similarly, this polar is divided to NRZ and RZ. Same with the bipolar, NRZ and RZ. And with this NRZ, there comes two options: NRZ with level and NRZ with invert. So we will look at all of these variations and categories in today's class. But before going to that, how you can select a specific or a particular line coding technique. So the line coding technique selection is basically dependent on some of the key factors, and the key factor involves these parameters, that you have to counter these things in mind, that what is the transmission bandwidth that is allocated to you, what is the power consumption that is allocated to you per bit, what is the bit error rate that up to which level you can tolerate this error rate, and what is the possibility of error correction and detection capability. If you There are several kind of coding techniques which allow you to have some kind of error detection and correction capability. So what kind of coding techniques are those? And in the last, what is the complexity level of that coding scheme? So before actually selecting a complex uh, line coding technique, you actually have to focus on these factors and these parameters. These are the key factors that need to be addressed before the selection of the any line coding technique in your digital data communication. So the first one is unipolar. This is very much simple. I will just explain this to you with an example. Let's see, we have data that is 10111010. This is your data. Now if you use unipolar and with NRZ, that is non-return to zero. Unipolar means one pole. You can see that there is only one pole with the amplitude plus A, and the other one has no poles, that is 0. So one amplitude is A and the other one is 0. So it is very simple. You just have to declare that my state 0 will be amplitude 0 and my 1 will be amplitude A. So whenever there comes 1, you have to draw a straight line for the whole symbol time, and when it comes to 0, you have to draw a 0 line, that is 0 amplitude line, for the whole symbol period or whole bit period. Similarly, there again come 1, so you have to draw a whole line for 1, and again there is 1, so you have to draw the whole time period as a bit period as a 1, and then again 0, and then again 1, complete line, not the center line. This is basically known as NRZ. The red line shows you the NRZ, that you have non-return to 0. Similarly, if you are asked to do it with the RZ factor, that is return to 0. Let me change the color of my pen because blue is as similar as black. So let's go with an orange, I guess. Yes, orange is good. It's differentiated. So if you use RZ, it means return to 0. So what do? For 1, instead of sending full A for the whole symbol period, you just send half of the wave as half of the symbol period as A, and then you come to 0. Similarly, if you are 0, you don't have to go anywhere, you have to follow this route as 0. Then again there come 1, and when there comes 1, you have to go at a amplitude A, but not for the whole symbol period, just for the half period, and then you again come to 0. Similarly, when again comes 1, you have to go to A, but not for complete symbol period, just for half symbol period, and after half you return to the 0. So this kind of wave is something like this, the orange one. So you see that this is kind of different as compared to the NRZ, and you can also analyze that NRZ, this RZ is basically less power consumption as compared to NRZ. NRZ use a transmitted whole symbol period as A. It means power is lost maximum. In this RZ, there is low power. Power is divided by half. So the power required to transmit the signal in RZ is as approximately half of the NRZ. So let's see the pros and cons. So the pros are this: it is very easy to implement this unipolar NRZ or RZ. They are very much easy to implement, and they are consuming less power. But the cons are they produce very high bit error rate based on Euclidean distance, because you see that there is very much low distance between 0 and A. Let's say A is plus 5 and 0 is 0. So the error rate will be the midline or the center line or the decision boundary will be at 2.5. So the error probability is much more higher, because if noise comes and it makes this 0 to 1, so it will be transmitted as 5. Because there is very much less error, Euclidean distance is very much less. This is known as Euclidean distance. This distance is basically Euclidean distance from center line towards the 5 and from center line towards the 0. So let's see polar. So again, there are two poles. The name shows that this is basically polar, and you can have two poles. This is basically bipolar. You can have multiple poles, 3 poles, 4 poles as well. Let's say we are using bipolar. 2 poles are there, plus A and minus A. So you can see that the things remain the same. For, let's say, we have declared that for 0 it will be uh, plus A, and for 1 it will be minus A. So whenever there comes 1, the thing becomes, sorry, this is basically straight. For 1 it is plus A, and for 0 it is minus A. This is minus A. So whenever there comes 1, so you have to go to the plus A. There is 1, so you have to go to the plus A, and if you are using RZ, you have to do half of the symbol period, but if you are using NRZ, you have to complete the period as A. Similarly, when there comes 0, you have to go to minus A actually. So when there comes 0, so you have to go to minus A, and if you are using NRZ, you have to complete the time period, a symbol period, and if you are using RZ, you just have to come back at 0 at certain point of time, that is half point of time. You have to come back to 0. Similarly, if you are again comes 1, you are going to have amplitude of plus A, and where comes 0, you have the amplitude of minus A. And you can see that as you have increased the Euclidean distance, that is, let's say, plus 5 and minus 5, this is plus 5 and this is minus 5. So the center line will be somewhere at the 0 point, and the distance will be 5 from each side. So it is very much less probable to have some kind of errors. So this is as compared to the unipolar. This provides you less bit error rate based upon the Euclidean distance. You can see that the distance has become twice of a. So you know that this distance has become 2 times 5, and this a is, let's suppose, 5. So this becomes 2a. So this is your polar NRZ and polar RZ. Let's come talk about bipolar energy. This is a kind of poles which where you have three poles. Actually, you are using three levels. This is basically bipolar energy, and you know that if it's energy, it will never come to zero for a half simple period. It will complete its time, and when there is a, there is one, it will go to a, and when there is zero, it will continue at zero. But whenever there comes one again, it will go to the opposite a. First it was plus a, and at the second one it will go to the minus a. Similarly, there comes next one, so it will go to the plus a, and then 0, and then again comes 1, so it will go to the minus a, and this thing will go on. And this is the benefit of using you are using as actually alternating voltage pulses for one, and it is very much convenient and easier for in terms of error detection. So if you see some kind of if you know that the transmitter is sending bipolar energy, and due to error you receive, instead of, let me change the marker color, instead of this thing you get this thing. Let's say you get this straight line. So you will be it will be very much clear to you that there is some kind of error in this, because you know that if it was 0, this should be straight line, and if it was 1, it should be on the upper side. But you received it at this side, let's say this side. So you will be instantly knowing that there is some kind of error here or here. So you will be able to understand or detect an error when using bipolar energy. We talked about the key factors that are important to discuss or selected before actually selecting of a particular line coding technique. So if any user or client asks you that he wants a good error detection technique, so you can recommend him bipolar energy. Let's talk about bipolar RZ. It produces the same thing, it produces the same levels, but instead of completing the whole time period or simple period, it only sends or transmit for half of the time. This is 1, then 0, there's again 1, there is a 1, so it will go in the opposite direction, alternating. You can see that the alternating voltage pulses for 1. So other one is like this, then again 0, then 1 on the upper side, then again it comes to 0, and the 0 straight line, and then again 1. So the last one was plus a, so this one should be minus a, and nothing goes on. So based on the previous amplitude of bit, it can detect error, as I have just told you. But the major disadvantage or limitation of this kind of bipolar technique is basically you have to store the previous information, that what was the last bit amplitude. It was either plus or minus, plus a or minus a. So you have to store some kind of thing in that memory as well. So memory will be required to store this kind of information. So let's talk about the further classifications, that is energy line and level and energy inverted. So there are some kind of change in this further energy. There are two more categories, L and I. If there is NRZ, you have asked to code it with NRZ level, so you just have to alternate the level. You can see that 0 stands for this and 1 stands for this. It is very much easy. You just have to change the level for zeros and 1. But when it comes to this NRZ inverted, you have to invert your signal whenever it comes 1. So it was the level 0, and whenever it comes 1, you have inverted the signal, and you have to continue that signal until and unless you gain again 1. You gain again 1 here, so you have to invert, and you will continue as far as another 1 comes in. So in this step there again comes 1, so you have to invert your signal. and you will have to continue this signal as far as the other one comes. So there comes one, so you have to alternate, and you will continue, and there comes one, you just have to alternate or invert your signal. So this is basically NRZ inverted and NRZ level. This is the minor difference between these two kind of coding techniques. The last and important technique that is used in the line coding technique is basically Manchester coding technique. And Manchester coding techniques, to analyze or remember it in very much easily, just have to memorize or remember the patterns. For 0 it means low to high transition, that is low to high transition, like this. And for 1, that is high to low transition. So this is 0 and this is your 1. So whenever it comes 1, you have to go from high level towards the low level, and whenever it comes to 0, you have to go from low level towards your high level. So this is basically a kind of, again, 1, high to low, again high to low, then low to high, then low to high, then high to low. So this is basically your Manchester coding, in which you have to create two panels or two combinations, that is high to low and low to high. So differential kind of Manchester coding technique is almostly same, but it's a little bit modified version of the Manchester coding technique. And in this coding technique, the polarity of the transmission signal is not important as the receiving end, but the transmission end. So this helps in self-synchronizing. For example, let's see what is in differential coding. You have to you have to create transition at the beginning of bit if you comes 0, and if you are receiving 1, there should be no transition. So whenever there comes 0, you are going from, let's say, high to low, and there is 1, so you will need no transition, you will carry on with this. And when again there is 0, so you have to, instead of going straight, you have to basically transit or make a transition. You are on the high, go to the low, and then comes to high, then again comes 0, you are at high, you have to go to 0 and start from the 0 and comes to high, and there comes 1, so no need of transition, again comes 1, no need of transition, and again comes 0, you are at high, go to low. Instead of going straight line and like this, you have to go this way. Similarly, there is 1, so no transition, and there is 0, so you go from low to high and start from there, ends on the low again, and there is again 0, so go from 0 to low to high, and again comes from high to low. So this kind of Manchester coding techniques are important as well, in comparison to other techniques as well. So let's see a quick question and a quick comparison. So this is a quick comparison for you, that which coding scheme provides you which benefit and which further benefits from themselves. So there is a quick comparison. Let's see which schemes provide us. So there is a comparison scheme, and you can see that comparison of these schemes, and you can see that if you are using Unipolar, it will provide, it will have you allow, it will allow you to use low bandwidth, and the complexity will be at least of the level, but you will have no control on the error and control or detection. And in the terms of the BER, you will have no control on that. When it comes to Unipolar RZ, so basically you have to have twice of the bandwidth, because you have to the time period is limited. You know that in RZ there is, you are basically coming back to 0 for half of the symbol time. So half of the time means double the frequency. If you are reducing the time of the symbol actually to half, so the bandwidth will be double, 2 times. You know the relationship between time and frequency. If you divide the time by 2, you are basically multiplying it with the frequency, that is you are taking the frequency twice. So this is the bandwidth that will be required, and this will be twice. And again, this is the least complex level, and you have no control on the error. Similarly, if you are using polar energy, it will provide some kind of in the middle of high and low. It will provide you less moderate bandwidth opportunity allocations, and the complexity level will be very much least, and there will be no control on the error. Similarly, the polar RZ, again the same, because you coming from NRZ to RZ, so the bandwidth is twice as you divide the time into half of the symbol period, and again the other things remain the same. When you are using bipolar energy and bipolar RZ, the bandwidth becomes requirement, it becomes very much low, and the complexity level should be there moderate. The complexity level has been increased from least to moderate. You can see that the complexity level has been increased, and the error chances, the error correction chances and detection probability and the techniques capabilities are, they are, you can detect a single bit of error. I've just told you in the previous examples that how you can detect a single bit of error. Let me show you. It was over here. You can see that you can detect a single error. You can either find the error from this side or on this side. You can easily, and you have, if you have the information of this previous one, so you can easily target that this was first upper one, this was alternate one, and this should be above one. This line should be this. So you have detected the single bit error from here based upon the memories and the record that was stored some kind of memory in the previous, and but for that you will have to pay for the memory cost. uh, and if you are using Manchester technique, the bandwidth requirement should be very much greater, and there is a least complexity level, but there is no error control. So this is your assignment number 3. Actually, it is mentioned 1, but this is assignment number 3 for you guys, that you have to find out which scheme is used in which application with spectral medium. I have already discussed 5 or 6 kind of mediums with you guys in the previous class of transmission medium. Now you just have to answer me that which technique is used in which kind of medium. This is your assignment, and I hope that you will be able to solve this example by combining the previous lectures information and today's lecture information. I will be very happy if you solve this assignment as soon as possible. So that's all for today. If you have any questions, I will be very much happy to have them in the class. And if you are not able to attend the class because of any genuine reason, you can also put forward your questions or queries or your confusions. You just have to email me at my email. You already have my email and my WhatsApp. You can ask me any questions, any kind of related questions into the email, as well as I will highly appreciate if you join the class tomorrow on Wednesday, inshallah. I will be very happy to have your good questions, and if you ask more questions, you will be learning a lot, because you know that the more you ask, the more you learn. That's all for today. I'll see you in the class. Thank you very much. Allah Hafiz.